In this video, I want to make sure that you know how to do the calculations we were doing from the first video. So you see three examples on the screen. 7.83 moles of calcium converted into atoms. 1.47 times 10 to the 21st atoms of oxygen. Actually, I used the wrong word there. I'll fix that. That should be molecules, because that's a group, my bad. Converted to moles. So these two questions are very similar to one another. Atoms is singles, that makes sense. Molecules are groups, and that's a group. And then in the third one, 3.46 times 10 to the 24th ions of sodium plus to moles. Now I want to talk about this one real quick. Ions, anything that has a charge. Okay, the word matches what it is. Okay, so you're going to do exactly the same math. 1 mole is 6.02 times 10 to the 23rd. I want you to pause the video and I want you to do the math to solve all three problems. And then after you're done with them, then hit play again and we'll check the answers. Let's see how you do. Go ahead and pause the video at this point. Alright, let's see how you did. Here's what you should have done. 7.83 moles, and I'm going to leave off because I don't have a lot of space. I'm going to leave out the CA for right now. And I know the word mole has to be on the bottom so that it can cancel. And mole is always 1. Always 1. By definition, if I'm going to use the word atoms, it's 6.02 times 10 to the 23rd atoms. So it's all calculator work. Let's see how you did. I'm going to take my calculator. And I'm going to take, since they're both on the top, I'm going to multiply them and divide by 1. So it's going to be 7.83 times 6.02 EE. Never use that time key there. I'm going to use the EE, 23rd power, equals. There's my long answer. So I'm going to look at what I have to begin with. This has 3 sig figs in it. So I'm going to put 3 in my answer. 4.71 and stop. The 3 doesn't make it round. 4.71 times 4.7, let me write it correctly. 1 times 10 to the 24th atoms. 4.71, and there's the answer. And that didn't come out on the screen very well, so let me drop that so you can see it. 4.71 times 10 to the 24th. My calculator does all the work for me. Notice these two are on the top, so I multiply them, and I get the answer. See how we did for the second one. On the second one, I start with what I'm given, 1.47 times 10 to the 21st molecules. Railroad track. Molecules goes on the bottom. Moles goes on the top. Moles is always 1. The word molecules disappears, and I'm going to put in 6.02 times 10 to the 23rd. So this time, top, line, and then a number on the bottom. So it's a division. Top divided by bottom. And I'm going to take it 3 sig figs again. So it's going to be, clear my calculator, 1.47 times 10, that's EE, 21, divided by 6.02 EE, 23. Calculator does it all for me. There's my answer, and I'm going to go 3 sig figs. Ah, this is a great example. Remember, zeros give us a problem. Those zeros right there are placeholders, so they don't count. So I'm going to go start with a 2, the 4, and the 4. So the answer is 0.00244. And that's my answer, 0.00244 moles. Question is, how do I know my answer is in moles? Very simply. Move it up so you can see the number a little bit better. Okay, a little bit more. Okay, how do I know that's my answer? It's the only word that's not marked out. So my answer has to be in moles. So I know that's the answer to the correct number of sig figs. If you've gotten this so far, you're doing great. Let's try the third example. 3.46 times 10 to the 24th ions. Remember, it's just a counting game, so it really doesn't matter if we're counting atoms, molecules, or ions. The same step is always true. Ions to moles. 1 mole, by definition, is going to be 6.02 times 10 to the 23rd. So again, it's going to be division, and I'm going to go 3 sig figs. Each of them happen to be this time 3 sig figs. They may not always be. 3.46 EE 24. divided by, because this is on the bottom, 6.02 EE 23. Answer, I'm going to go 3 sig figs. That means I'm going to go 5, 7, 4, stop. The 7 makes it round, so it's 5.75. 5.75 moles of Na plus ions. So you'll notice in all three of them, I'm using the same step. You'll notice that in all three of them, I have 1 mole and Avogadro's number, 1 mole and Avogadro's number, 1 mole and Avogadro's number. The only difference is placement. Whatever I need to mark out is where I put mole and mole here. Here I needed molecules to disappear, so I flipped the steps. And on the bottom one, I need the word ions. The word mole is nothing but a quantity, just like the word dozen. It's just a really big number because atoms are so small. Now I'm going to give you one quick hint. Make sure you get them all right every time, and here it is. Whenever you have the word mole, you're always going to have a 1. Always. Whenever you have the word atoms, molecules, or ions, any of those, you're going to have Avogadro's number every time. Every time. So that number is always used with these 3 words, and that number is always used with moles. We'll never break that rule. It's always going to be the case. Good job. I bet you got them right. And what we're going to do in class is we're going to take this and we're going to go a step further. We're going to talk about how much is a mole. How much does a mole weigh? Now the answer to that is very simple. If I wanted to know how much this weighs, I wonder if it weighs as much as the calculator. Well, the answer is obviously no. But I have one of those and one of those. Everything weighs different. And so we're going to talk about how do you know how much something has in mass. So even though I have the same quantity, does that mean they have the same mass? No. And we're going to figure out how to do that in class. So first I wanted you to be able to master what a mole was, remember using the words, and in class we're going to go from there. We're going to talk about how to calculate mass. It's very simple. That handy dandy periodic table that we use over and over, that's what we're going to use. See you in class.